All right, so let's talk about the strategy for how do we choose u. And kind of the strategy for how we choose u relates back to our basic antiderivatives. So we want to keep in mind a lot of those elementary form antiderivatives that we have listed out. And probably the most frequent ones that we see are the power rule, 1 over u, kind of the exception to the power rule, natural exponential functions, and then we have ones for trig and inverse trig functions. So those are some of our more common ones. All right, so first of all, we have our power rule right here. And this power rule, we know it works for every single n value except, so this works for n, we'll just say n not equal to -1. If n is equal to -1, well then we're in this other case. So this is sort of the exception. So these first two are sort of related to each other. Power rule just about always works except when the exponent is -1. There it doesn't work. And that's when we have this exception. All right, so keep in mind these basic antiderivatives. So when we're looking at we have an integral that we're trying to do. And it's complicated looking, and we think we're going to use substitution rule. How do we choose u? Well, we look at the pieces of our function. And if we see something complicated inside parentheses, and it's all being raised to the power n, well, that's telling us we have a power function, sort of an outer function. And so what we're going to do is we're going to let u equal the terms that are inside the parentheses. So if you see parentheses and then you see something complicated inside the parentheses, it's a good indication that those terms that are inside the parentheses, that's going to be what you choose for u. And so generally what we're doing is we're choosing u to be the inner function. That's the overall strategy here. Generally we try to choose u. Not always. There are different cases where we might do something different, but a lot of times we want to choose u to be the inner function. So when we have a composite function, that's why it's really important to be able to identify, well, what's the inner function, what's the outer function? And so for our substitution rule, what we're trying to do is we're trying to identify the inner function so we can really integrate the outer function. So if we see parentheses and then everything raised to the power n, well, we're going to let u equal the terms that are inside the parentheses because we have this power rule that helps us do it. If we're looking at our function and we see a fraction, so 1 over some complicated terms, well, in that case, we're going to let u equal the terms that are inside the denominator. And if we're going along and we see an exponential function and the terms in the exponent there, it's not just x, it's a whole bunch of terms. Well, then we're going to let u equal the terms that are inside the exponent. And if we have a trig function, and inside the parentheses that go along with that trig function, it's not just x. So it's not like just sine x. It's sine of something more complicated. Well, then, you guessed it, we're going to let u equal those terms that are inside the parentheses. Terms inside the exponent, terms inside the parentheses. So the tell, a lot of the time, not always, but a lot of the time, is if you see parentheses and then some complicated, or not just x, but some complicated terms inside those parentheses, generally that's how we're choosing u. We're letting u equal that inner function. what's in the parentheses. All right, so we're going to try some more examples, but this is really the kind of the most common strategy for how we pick U. Now, there are some cases where this might not work, so it's not always a science here. It becomes more of just a kind of an art, choosing U and how to do that. But this is a good place to start. So we're going to definitely practice more of these. It just comes with practice. So we'll see it in the examples coming up.